In this video, I'll be discussing systems of equations with three variables and how to solve them. When you're thinking of three variables in a graph, you're thinking of a three-dimensional figure. You have some value for x, you have some value for y, and then you have this third dimension out in space of the some value for p. It is denoted by x, y, z in that order. So for example, the coordinate point 5, 1, negative 2 is a solution for the systems of equations. If you plug in 5 for x and plug in 1 for y and plug in negative 2 for z, you will get negative 4. And it will work for all three of these equations. There are different types of solutions that are possible. We are only going to be discussing today about a single solution, but there are many different. The reason we are dealing with planes is we're dealing with three variables, which means back in geometry we discussed that any 3 points create a plane. So you can have a single solution when 3 planes all intersect. There's another way for planes to intersect using from a straight line. They have points of a line in common. You could have all 3 planes being the same. They could all be parallel, or only 2 will intersect each other at a time. But for the reference of today, we'll be discussing a single solution. So to solve a system of equations in this way, we are already given z. So what we can do is we can plug z into our second equation and solve for y. So therefore, y will equal a negative 4. And now that we know the coordinate points of y and we know the coordinate point of z, we can plug them both in to find x. So x plus 2y plus 3z equals 6. So x minus 8 plus 6 equals 6. Negative 8 and 6 give me a negative 2. And then to solve for x, I would add 2 and I would get 8. So the solution to this system of equations will be 8, negative 4, and 2. It always goes x, y, and z. Now in this case, we do not know z or y or x. So here is what you do step by step. First thing we need to do is we need to eliminate a variable. So choose any 2 equations to eliminate the variable. I'm going to choose the first and the second equation in order to eliminate the z. So I will have 2x plus y minus z equals 5. And then I have x plus 4y plus 2z equals 16. In order to eliminate the z's, I'm going to have to multiply the top equation by 2 in order for the z's to eliminate each other. So when I multiply by 2, I will get 4x plus 2y minus 2z equals 10. On the bottom, nothing changes. And now I can add these 2 equations together. The z's cancel. I'll be left with 5x plus 6y equals 26. You're going to say we have a problem, we still have 2 variables. Yes, we do. So therefore, you need to go back and choose 2 more equations to also eliminate the z. So I am going to now choose the second and third equation to eliminate the z, which will be very easy because a 2 and a negative 2 will already cancel each other. So if I take x plus 4y plus 2z equals 16, 15x plus 6y minus 2z equals 12, and I add these together, I will get 16x plus 10y. The z's eliminate each other, giving you 28. So if you notice, now I have a systems of equations with 2 variables. I have a systems of equations with 2 variables. And now I have 2 variables with 2 equations that I can now solve for. So I need to determine whether I'm going to eliminate the x or am I going to eliminate the y. So the least common multiple between 5 and 16 is going to be 80. The least common multiple between 6 and 10 is going to be 30. So if I need 6y and 10y to become a 30y, then I'm going to need to multiply the top equation by 5 I'm going to need to multiply the bottom equation by 3. When I do that, the top equation is going to give me 25x plus 30y, I don't know why I keep doing that, equals 120, or I think 130. Yes, just want to make sure it equals 130. And then on bottom, I will get 48x plus 30y equals 28 times 3, which is 84. The only problem is they're both positive, so I'm going to make the bottom equation become a -3. So I'm going to make all of the bottom equation be negatives. Now I can add my equations together. The y's will eliminate. -48 and a -25 give me a -23x. And 130 and a -84 give me 46. Divide by -23 and you get a -2. We have now found one of our variables. Now we need to plug -2 back in to find the other one. So I'm going to take the top equation. I'm going to plug -2 in for x. 5 times -2 is -10. I'm going to add 10 to both sides and I'll get 36. Divide by 6 and I get 6. We now have two variables that are solved. Now we need to find the third. We need to find z. So I'm going to choose my top equation. We know it's going to be 2x plus y minus z equals 5. That gives me -4 plus 6 minus z equals 5. -4 plus 6 is 2. I'm going to subtract 2 to get 3, and I need to divide by a -1, and I will get a -3. So our final solution is -2, 6, -3. For a word problem, a sporting goods store sells footballs, basketballs, and volleyballs. A football costs $35, a basketball costs $25, and a volleyball costs $15. On a given day, the store sold 5 times as many footballs as volleyballs, and they brought in a total of $3,750. So we know, I'm going to say the F stands for football. I'm going to say B stands for basketball. And V stands for volleyball. I know that a football, the cost of a football is $35, plus the cost of a basketball is $25, plus the cost of a volleyball is $15, and that's going to bring in $3,750. On a given day, the store sold 5 times as many footballs as volleyballs. So if you think of the number of footballs, it's got to be 5 times the number of volleyballs. So the number of footballs is 5 times the number of volleyballs. And then the money made from basketballs alone, so here's the deal. The money made from basketballs alone, how much was a basketball? So 25 times B, because again it says the money made from basketball was 4 times the money made from volleyballs. Is $15 per volleyball. So we will have the equation 35F plus 25B plus 15V equals 3750. We will have F minus, will be plus 0B minus 5V equals 0 because I had to solve the second equation. I need to line up the F, the B, and the V. So in order to do that, I had to subtract 5V. There was no basketball in this case, so that's why there's a 0. And then we have 25B, and I have to subtract a 60V because 4 times 15 is 60. There was no F, so I am going to write a 0F. This is my systems of equations that I will then need to solve. And at the end of this video, I will come back and solve this to show you how it is done. A change machine contains nickels, dimes, and quarters. So I'm going to use N for the number of nickels, D for the number of dimes, and Q for the number of quarters. There are 75 coins in the machine, so the number of nickels plus the number of dimes plus the number of quarters will equal 75. The value is 725. So if every nickel is worth 5 cents, every dime is worth 10 cents, and every quarter is worth 25 cents, then that is going to equal a value of 725 cents. I'm not fond of decimals, so I just removed all the decimals by using it in cents. Just make sure that the decimal is removed here too. And then there are 5 times as many nickels as dimes. So how many ever dimes there are 5 times as many nickels. So if you have the number of nickels, you've got to multiply the number of dimes by 5, right? Because there's 5 times as many nickels. So how many ever nickels there are, you need 5 times the number of dimes. The top two equations are already written correctly. The variables line up, but in order for the bottom one to line up, I will need to subtract 5D. There are no Q's, so I'm going to use 0, and that equals 0. Again, that is a system of equations, and I will come back at the end of the video to solve it. So what I'm going to do is I'm going to take the first 2 equations and I'm going to eliminate the V's. I'm going to multiply the second equation by 3, and I will get a 15 and a negative 15. So over here, I'll get 35F plus 25B plus 15V equals 3750. And then I'm going to multiply the bottom equation by 3. So I'll get 3F minus 15V equals 0. When I add these together, I will get 38F 25B equals 3750. Now what I'm going to do is I'm going to take the 2 bottom equations and also eliminate the V. So I'm going to have, so there's my first equation that has F and B. My second equation is going to be, I need to multiply the top by negative 12 because negative 12 times 5 will give me a positive 60, which will cancel. So it will give me negative 12F plus 60V equals 0 because negative 12 times 5 is a positive 60. And then I'll get 25B, which goes in the middle, minus 60V equals 0. When I add these together, the V's cancel, leaving me a negative 12F plus 25B equals 0. And now I have 2 equations that have F and B in them. The great thing is they both have a 25B, which means I actually can cancel them together. So I'll have 38F plus 25B equals 3750. And then on the bottom, I'm going to change the sign so that it becomes a negative. I'm going to multiply this by a negative 1. So I'll get 12F minus 25B equals 0. When I add these equations together, I will get 50F is equal to 3750. So 3750 divided by 50 gives me 75 footballs. We now know one of them. Now we're going to plug F back into, I'm going to plug into this middle equation. If I plug in 75, I will get 75 minus 5V equals 0. So 75 equals 5V. So V equals 15. And now we know F and V, we can now plug we can plug V back into here in order to find B. So we know 25B minus 60V equals 0. 60 times 15 gives you 900. So 25B equals 900. And 900 divided by 25 gives you 36. So, therefore, somewhere around here, the number of footballs sold were 75, the number of basketballs sold was 36, and the number of volleyball sold was 15. Next, nickels and dimes. I'm going to go back and eliminate anything that had a 0. Now I need to eliminate something. I'm going to take the second and the third equation and eliminate the d by multiplying the denominator, the second equation, the third equation by 2, because 2 times 5 will give me a negative 10. So I will get 5n plus 10d plus 25q equals 725. And then I will get I'm multiplying it by 2. I will get a 2n minus 10d equals 0. So those will eliminate, leaving me 7n plus 25q equals 725. There's my first equation. Now I need to eliminate the d in another place. So I'm going to take the first two equations. I'm going to multiply the top by a negative 10 so that it will cancel with this positive 10. So negative 10n minus 10d minus 10q is going to give me a negative 750 because I multiply by negative 10. And then on bottom, I'm left with 5n plus 10d plus 25q equals 725. When I add them together, I'll get a negative 5n, a positive 15q, and that equals a negative 25. I now have two equations to be able to solve. So I have 7n plus 25q plus 725 and negative 5n plus 15q equals negative 25. I'm going to do something. I noticed that there is a multiple in here. I can divide the entire thing by 5. I'll get a negative n. If I divide this by 5, I'll get a 3q. And I divide this by 5, I'll get a negative 5. This will make it much easier to be able to eliminate. I'm going to multiply the bottom equation by 7 so that the n's cancel. So I'm left with the top is 7n plus 25q equals 725. The bottom is a negative 7n plus 21q equals a negative 35. So when I add these together, the n's cancel. 25 and 21 are going to give me a 46q, and 725 and negative 35 is going to give me a 690. So when I divide 690 by 46, I will get q equals 15. That means there are 15 quarters. Now what I need to do is plug that back into one of these equations. So I'm going to plug it into this one right here. So negative n plus 3q equals negative 5. So negative n equals a negative 20 because 3 times 15 is not 20. 3 times 15 is 45, and I subtract 45 and I'll get negative 50. So n equals 50. And then I'm going to use n and plug it into here. So 50 minus 5d equals 0. So 5d equals 50, and so d equals 10. That means there were 50 nickels, there were 10 dimes, and there were 15 quarters.